This example shows how to use the Data Analysis add-in to calculate regression results. For this is the original data from the regression, and if we go to the Data tab, on the far right is Data Analysis. If this doesn't appear on your Data tab, you need to go through the add-in procedure. The Data Analysis is already there, it just doesn't show. Click on Data Analysis and go down to Regression. Click OK. The regression dialog box comes up. The first thing we need to do is to input the Y range, which is statistics grade. Then the X range, aptitude test score. There are other things that we can put in here, labels, we can force the regression through 0 and so forth, but our main thing is the output range. We want to put it on this same page, so we choose output range, click in there and just choose a spot. This will be the upper left-hand corner of the regression results. Again, there are more options down at the bottom, and if you need those, you will recognize them. Click OK, and these are the regression results. Here is the R-square for this data, 0.4803. This is the correlation coefficient, the square root of the R-square, 0.693. In this part of the table are the coefficients. The value of the intercept is 26.78. The value of the slope, called X variable, is 0.6438. There is a variety of other information in here, all of which tells you how well the regression has done. For example, here are the upper and lower limits for the confidence interval for the intercept. The lower limit is -70 and the upper limit is 123. This basically says that the intercept can be any value between -70 and 123, which includes 0, so that the slope could in fact be 0. Excuse me, the intercept could be 0. The value for the slope also includes 1, so that if the slope is 1, there is no regression. It is just simply a flat line, so that these can be used to determine what those characteristics are. T-statistics for each of the intercept and the slope are shown here and can be used to calculate the confidence intervals. Here is the residual sum of squares, just as we calculated it in another exercise. This is the value that is a minimum for the regression. All of these provide many more decimals than are actually needed. Although people report 5, 6, 7 decimals without blinking an eye. That really isn't necessary. You can't tell the difference between the prediction with 7 decimals or 6 decimals. So this is the table produced by the regression function in data analysis.